Welcome back. This video is recorded on request of one of our student who requested to explain this problem. And the statement of this problem is an aluminum pole for a street light weighs 4,600 Newton and support an arm that weighs 660 Newton. See figure. The center of gravity of the arm is 1.2 meter away from the axis of pole. A wind force of 300 Newton also act in negative y direction at 9 meter above the base. The outside diameter of the pole is 225 millimeter and thickness is 18 millimeter. Determine the maximum tensile and compressive stresses respectively in the pole at the base due to weight and the wind force. So you can see this is street light and this is the pole. The weight of this street light is 660 Newton and weight of this pole is 4,600 Newton, and the wind force that is acting 300 Newton meter, that is about 9 meter from this base. So you have to find the tensile and compressive force at the base. The cross section of this pole is given as outer diameter is 225 millimeter and thickness is 18 millimeter. So let's start with the solution. What we will do is that first step is that if you remove this weight of this street light, that is 660 Newton, to the axis of this pole. So if I move it like this, there this is W2 and that is equal to 660 Newton. And since this weight is away, this weight is acting at the center of gravity and that is away 1.2 meter from the pole. So definitely it will create a moment that is like this. This is counterclockwise movement. So we will represent this movement over here, that is like this, and this movement M2 will be equal to 660 multiplied by 1.2 meter. Okay. And what we will do is that you can see this is y-axis, this is x-axis, and at the base when you find reaction forces, so at the base the forces will be like this. It will be the vertical reaction force will be like this, that this will be equal to PZ because it is in Z direction. And similarly you will having a shear force in this Y direction which is represented as Vy, and you can see that due to this movement and this force into perpendicular distance of 9 is also producing movement in clockwise direction. So we have reaction moment which will be equal to mx because this is about x-axis. So I can write it, the moment is like this, which is mx. So we'll find this pz, py, pz, Vy and Mx by using equation of equilibrium. Also this W1 which is 4,600, that is acting downward. So I have to represent it as well. Now we'll apply the equation of equilibrium. So first equation of equilibrium is that sum of all forces along Z direction must be equal to 0 and upward force is taken as positive. So you can see along Z direction one force is this one which is minus 660. The second force is this 4,600 which is also negative because it is downward, plus this PZ which is acting upward is equal to 0. So I will calculate it. 660 plus 4,600 will give you 5260. So it means that PZ will be equal to 5260 Newton. Now we will find this Vy by using another equation, that sum of all forces along y direction must be equal to 0. And you can see y direction is this direction, so force in this direction is taken as positive. So Vy is acting minus this 300 Newton force that is acting along negative y-axis. Their sum must be equal to 0. So from here you will get this Vy will be equal to 300 Newton. Now the last thing is moment. So what we will do is that we will take the third equation of equilibrium, that sum of all moment about x-axis must be equal to 0 and taking the counterclockwise moment as positive. So you can see this is x-axis. So first moment about this x-axis is m2 which is 660 multiplied by 1.2 and that is counterclockwise, so it will be positive. So I can write here that 660 multiplied by 1.2, The second moment is due to this load, which is 300 and perpendicular distance 9, and this is producing counterclockwise movement about x-axis. So I can write plus 300 into 9, and this mx reaction moment at the base, which is negative, and that is because this is due to clockwise movement. So again, when you solve this, mx will be equal to, I will calculate it, 660 multiplied by 1.2 is 792 plus 300 multiplied by 9 is 2700. So 2700 plus 792 plus 792, that is making a moment about x-axis is 3492, and unit will be Newton into meter. Now you have all these forces and movement. So you can see here at the base, you can see you have one force is this one, that is compressive force, and other is movement. So this is the case of combined loading. So I can write it over here. So this is called combined loading because you have normal stress. This is normal stress, clear, that is acting on the section, and there is a moment mx which is producing bending stress in the this x direction. Okay, again you can see that this is the force which is producing normal stress in z direction, and due to this movement about x-axis, this produce bending stress in z direction. So this is the combined loading case. So for that we have stress is equal to minus P by A, which is normal stress, plus minus this moment mx, and y is distance from the center or neutral axis to the outer section, divided by I double x. So what is I, what is y? So you can see if this is your neutral axis, this is your, let's say this is your neutral axis, because you can see x-axis is this one. So moment is acting like this. So this will be your neutral axis, and this will be your distance y, and this y will be equal to outer diameter, which is 225 divided by 2. 225 divided by 2. Okay, what we will have to do is that we have to first calculate area. So area cross section is given as, so area will be equal to pi by 4 d1 square minus d2 square. What is d1? So d1 is outer diameter, which is 225 millimeter. This is your d1, and thickness t is given as 18 millimeter. So you can see that d2 will be equal to, which is inner diameter, so inner diameter will be equal to d1 minus 2 times thickness. Let me show over here. This is outer diameter, so smaller or inner diameter will be equal to this 225 minus this thickness plus this thickness. So d1 minus 2 times of thickness. Also I will write it outer diameter, outer dia, this is thickness, and this is inner dia. So what 225 minus 2 times 18 will give you inner diameter. So inner diameter will be equal to 189 millimeter. Or you can also say that d2 is equal to 0.189 meter. Now you have all these values. So area, cross-sectional area of this pole will be given as A is pi by 4 multiplied by d1 is, this is d1 which is 0.225 power 2 minus d1 is inner diameter, d2 is inner diameter, which is 0.189 square. So when you solve this, you will get area will be equal to 0.011759 square meter. Now we have this A, so we'll find this I double X. So I double X, let me write it over here. Moment, second moment of inertia of this cross section about this neutral axis will be equal to pi by 64 into outer dia, which is outer dia power 4 minus inner dia power 4. So pi by 64 multiplied by outer dia is 0.225 power 4 minus inner dia is 0.189 power 4. So when you solve this, you will get I double x, second moment of inertia about x-axis, will be equal to 0.100006317 and unit will be meter power 4. Now you have all these values. You can see you have P, you have mx, you have y, ix and a as well. So you can just plug it in this formula. So for tension, for tensile stress, you can see this will be equal to minus P divided by A. So this will be positive mx into y divided by I double x. And this px will be pz because this is compressive stress. So put the value pz is how much? 5260. So 5260 divided by this area, which is 0.0117059. This is negative because compressive, plus mx. mx is 3492 and this y is this distance 225 divided by 2. So in meter it is 0.225 divided by 2 and I is this one 0.00006317. That will give you tensile stress. So if you further simplify, this first value will give you minus 480099.7 plus this value will give you 6218933.038. So when you solve this, when you add them, it will give you 5378833.338 and unit will be Newton per square meter. So if you want to convert it into kilopascal, because Newton per meter square is Pascal, so it will be equal to 573.833 kilopascal. Or if you want to convert it into megapascal, so this tensile stress will be equal to 1, 2, 3, 4, 5, 6. So it will be 5.74 megapascal. So this is the tensile stress. Now we will calculate the compressive stress. So I will write it compressive stress. So compressive stress is represented as sigma c and that will be equal to minus pz by A minus mx into y divided by ixx. So put the value minus 5260 divided by 0.0117059 minus 3492 multiply by 0.225 divided by 2 divided by I, which is 0.00006317. So when you solve this, you will get the first term will give you minus 480099.7 and the second term will give you minus 6218933.038. So when you add them, it will give you minus 6699032.73 Newton per square meter, or in kilopascal it will be minus 6699.03 kilopascal, and in megapascal it will be minus 6.7 megapascal. And if you want to remove the negative sign, so you can just write it sigma c is minus 6.7 megapascal and that is in compression. So these two are the answers of our this question. Also let me show you that due to this movement, this portion will be in tension because this will cause elongation in this portion and this will be in compression. but both values, the upper one will be positive and both lower one will be negative. But why here and here they both are equal? And this was all about this problem 5.12-2 that is requested by one of the students from YouTube who requested to solve this. I hope you enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.